Okay, today's topic will be the three-phase voltage generation. So three-phase voltage generation means that three generators at the different phase are connected. So this is a three-phase voltage generation. So there are the three generators, A phase, and the B phase, and the C phase. So those generators or the neutral combined. So this one is connected to load here. So we connect the voltage like this. So this is similar to this way. This is the A phase. This is A phase voltage, and this is B phase voltage source, and the C phase voltage source. So they connect to load here. Load will be the star connected load. And this neutral is connected like this. So this is a three-phase voltage generation. So this three-phase voltage generation, you can write the waveform. Waveform means the EAM is this coming here, this waveform. So this is EAM. 0 like this. And this is a 120 degree. So this becomes an EBM wave start. EBM wave start. And 240 degrees. So ECM wave start. So this means that EA is equal to EAN psi omega T. Similarly, EB. EAN psi omega T minus 120, and then EC. ECN, this is EBN, psi omega T minus 240 degrees. So this is a voltage representation. EA, EB, EC voltage representation. So if you combine the all voltage together, EAN plus EBN plus ECN. So this becomes the EAN is the E angle 0. This one you can also write the E angle 0. This one you can also write the E angle minus 120. This is the E angle minus 240. So E angle 0 plus E angle minus 120 plus E angle plus 120. So this becomes the E cos 0 plus J sin 0 plus E cos 120 minus J sin 120 plus E cos 120 plus J sin 120. So this becomes the E 1 plus J0 plus E cos minus 120 becomes the minus 0.5 plus J 0.866 plus E, this is the cos minus, this is minus 0.5 minus J 0.866. So everything becomes a 0. So this way, you combine all three phase voltage, all becomes a 0. Today's topic will be the three-phase voltage generation. So three-phase voltage generation means that three generators at the different. Okay, phasor notation means that we can represent the voltage by the phasor diagram. For example, this is the resistor, this is A point, and this is resistor R1. So this is the B point. Between A and B, resistor is connected. So A point is the positive, the current flow is I. So this is the voltage draw across the resistor. So this is V1 or the VR. The voltage draw across the resistor. So this voltage draw across the resistor can be represented by V1 or VR. Okay, similarly, we can draw the circuit. So this is the V1, we represent by this way. Okay, this circuit. So this is A. So resistor B. So this is a Z1. So this is Z2. This is a C. And a Z3. And finally go to the D point. So ABCD wave like this. So we can measure the voltage. The voltage draw across AD. VAD is equal to VAB plus BBC plus BCD. So this is the VAD equal to VAB plus BBC plus BCD. So we can also measure the vector diagram. VAD vector is equal to vector VAB plus vector BBC plus vector BCD. So by this way you can measure. So this is the AB and the BC and the CD. So this is total become the VAD. So by this way we can measure the vector. So this is the vector representation or the graphical representation. Okay, so another thing is the vector direction. If you measure the vector VAB in this direction, in this case, VBA will be the opposite direction. So VBA vector is opposite to VAB vector. So those are the vectors here. So this is the two vectors you can, same direction you can add. So for example, this vector here, this is V1 plus V2. So V1 plus V2 you can add, this is the V1 and V2.
What's the difference in the No, okay.
Yes. This one?
Just about it. The diagram.
That one.
Yeah. What's that? Is that D?
This is D.
That's D.
Okay, so this V1 plus V2, this is V1 plus V2 is a summation. If this is a V1 here and a V2 here. V1 and V2 this direction, this becomes this is the V1 minus V2. Different direction, you have to subtract. Same direction, you have to add. So now you got the vector here. This is the VAB. So this is VAB. And this is VBC. This is case 1, case 2, and case 3, and case 4. So now we add the two vectors parallel. So this is VAB vector, and this is a VBC vector. So this one parallel combination means this one with parallel combination. So this vector total. This is a V total, VAC. So VAC vector is VAB vector plus VBC vector. So this diagonal is represented VAC vector. Then we saw the one example. So another one is a representation. So this is a zero line. So VAB vector this direction is a positive 45 degree. So this means VAB angle positive 45 degree. And this one go to this one is negative. So this means that VAB angle negative 45 degree. So we can also represent like this way. Then we can start to the problem 1. If VAB equal to 240 angle 0 degree volt and BCD equal to 240 angle minus 120 degree volt.
That red line there, that BC, it's just supposed to be a straight line.
Yes, straight line. The BC should be the straight line. But when we join them, if the VAB 240 degrees angle 0 and the BCD 240 minus 120 volt, using a phasor diagram, find the value of AB and CD. Using a polar diagram, find the value of VAB angle 240 angle 0 and the BCD 240 minus 180. So using this phasor diagram, find the value of VAB plus BCD. So now we will draw the phasor diagram here. VAB 240 angle 0 is this one. This is the VAB. 240 angle 0. So this multiplication is 240. So this will be the reference line. And BCD minus 120. So this is a 240 angle minus 120. So this is BCD. So minus 120. BCD and 240 angle minus 120. So then you have to add the two vector main. You have to make the parallelogram, and then this center. This line will be, this is a diagonal line will be there, VAB plus BCD. So this one is a diagonal line, so you can call the answer. So you draw the thing and then you measure this one, and this becomes a VAB plus BCD. Okay, this one. So VAN is 200 angle 40 degree. VBN is at 240 minus 120. So you have to find the VAB. So in this case, we have to use the equation. The equation means that the VAB is a VAN minus VBN. Also, if you see the BBC. So VBN minus VCN. Similarly, VCA, so VCN minus VAN. So this is the formula. AB is a ABN minus VN, BC is BN minus CN, CA is a VCN minus VAN. So this is the solid formula. So now we use the formula and then we will draw the setup diagram. So firstly we draw the VAN. VAN is 240 angle 0. So this is 240 angle 0 degree volt. So this is the VAN. Okay, and VBA is 240 minus 120. So this is minus, you have to rotate this way. So this is a minus 120 degree. Minus 120 degree, this voltage is 240 angle minus 120 degree pole. So this is M point, so this is A, B. So this is a VMB. VMB is equal to 240 minus 120 degree pole. So this voltage we can make. This is the VBN. So this is VBN 240 angle minus 120. So this voltage VBN 240 angle minus 120. Now we want to find the VAB. VAB formula. This is the VAN minus VBN. VAN minus VBN. So this becomes the VAN is, we can say like the VBN plus minus VBN. Okay, so VAN is the same. We don't change the thing. Minus VBN. So VBN is this one. This is the VBN. So this is the minus VBN. Minus VBN. So minus VBN equal to 240. So this is become the angle 60 degree. Because this line, you reverse. By reversing this one, magnitude doesn't change, but big angle becomes the plus 60 degree. Then you can make the parallelogram. So this becomes this component is VAB because this becomes the VAN plus minus VBN. So this is why you got the VAB. So this diagram, VBA is given 240 angle 0, VBA is 240 angle minus 120. So we have to use a VAB. So we follow the formula. VAB is VAN minus VBN, VBC is VBN minus VCN, VCA is VCN minus VAN. So we use the formula. So originally we draw the VAN. VAN 240 angle 0, VBN is minus 120. Now we want the VAN minus VBN. This means VAN plus minus VBN. VBA reverse. Reversing minus VBA 240 angle 60. Then you make the parallelogram. This diagonal becomes the VAB. So this is the way to construct the phasor diagram.